A scatter diagram or scatter graph shows the relationship between two variables. Imagine that you sell ice creams and you want to draw a scatter diagram of ice cream sales against the temperature. Each day you will count how many ice creams you sold and measure the temperature at midday. You then whip out your scatter diagram and put a cross at the right place. After a year you will have lots of beautiful crosses on your scatter diagram. What you notice is that on the colder days you sell less ice creams and on the hotter days you sell more. You have just discovered a correlation. Correlations can be different types and strengths. If they go up, as you go from left to right, the type is positive. If they go down, their type is negative. If all the points are close to the line of best fit, which we'll talk about in a second, then the strength is strong. If the points don't line up so nicely, the correlation is weak. Sometimes you may be asked to describe the relationship between the two variables. For this, you can fill in the blanks in the sentence as the variable at the bottom increases, the variable on the left either increases or decreases. Looking back at our ice cream example, you would say, as the temperature increases, the ice cream sales increase. The relationship between the age of a car and its value may give you the relationship of, as the age of the car increases, the value decreases. But what if you can't draw a line of best fit? Well, then we say there is no correlation, although you may have a nonlinear relationship, but we don't need to worry about that for now. I give out this advice to all my students, and if you are reading this, I suppose you're worthy of this advice as well. Anytime you see a scatter diagram, always draw a line of best fit on it, even if the question doesn't ask you to. Chances are you will need it. A line of best fit is a line that describes the relationship on a scatter diagram. There are a few simple rules to drawing one. The line must go with the data. Make sure that you have a transparent ruler and rest it on top of the scatter diagram. Move it until it's lined up with the data. There should be roughly the same amount of points above and below the line. There is a mathematical way to find the exact equation of a line of best fit, but that is not assessed. For your exam, you will need to take a good guess at where you think the line should be. You can do this by roughly making sure that there are the same amount of points above and below the line you draw. Having said this, I have had to intervene when one of my panicked students was attempting to rob hers out because there were 8 points below and 5 above. This rule uses the word roughly because an 8-5 split is absolutely fine. In fact, the mathematical way of doing it may also have an 8-5 split depending on the relative distances each pointer are away from the line of best fit. Your line does not have to pass the origin. Since most scatter diagrams only use positive measurements, I'm not sure how you would draw a negative correlation if all scatter diagrams had to go through 0, 0, but remember, they don't. Life is messy, and there can be all sorts of things that get in the way of nice clean data. An outlier is a point which clearly doesn't belong. It sits away from the line of best fit and can have really interesting reasons why it exists. Try to look at the context of the question and give a good reason why the outlier happened. If we have a scatter diagram of coffee sales against the temperature, the line of best fit is showing a lovely strong negative correlation, but our outlier is showing fantastic sales on a hot day. What could be the reason for this? To answer this question, we have to do something that many mathematicians can find difficult. We have to speculate with our imagination. Perhaps the coffee shop was running a sale that day, or maybe there was a music festival happening across the road. With scatter diagrams, there are two types of predictions or estimates you can make: interpolation and extrapolation. This scatter diagram shows maths and English marks on a quiz. Let's use the line of best fit to estimate what a student would get in their maths quiz if they got 4 on the English quiz. We will start by drawing a line up from 4 until our line of best fit, and then across, and we see that they will probably get roughly 6 on the maths quiz. This estimate is reliable because we're using the line of best fit in the part of the scatter diagram that has data around it. This is called interpolation. Now let's use the line of best fit to estimate what a student would get in their maths quiz if they got 8 on their English quiz. We do the same steps, line up and across, and we would estimate that they'd probably get about 4 on the maths quiz. This estimate, however, is not reliable. You can see that we only have data for students up to a mark of 6 on the English test. We do not know if this relationship continued. This is called extrapolation. A great way of thinking about extrapolation is imagine doing a scatter diagram of age against height, but only measuring people up until they're 15. As you would imagine, the line of best fit would show that the older you get, the taller you become. But if we keep the line going, we estimate that a 90-year-old is the size of a house. We all know that people stop growing, so the linear relationship would also stop. There is a saying that you need to remember when working with scatter diagrams. Correlation is not causation. What this means is that you may find that the more revision guides you have, the better the maths test scores. But the real reason for this link is more likely that the students that revise more will have more revision books, thus have better test results.